Hi, I'm excited to be here. My name is Saar Rachamim. I work at a company named Get as an automation tech lead. Get's product is a mobile application that connects between a rider and a taxi driver. It is in the same marketplace as Uber and Lyft. It's a great company with a great product, a product that is developed and loved by its quality. As part of my daily work, I support automation developers. I lead them in the tech aspect of the work, and I do my best to remove any obstacles that they have and to solve complex problems if there are any. As any other guy, I'm also taking taxi rides. And after I started to work at Get, I started to mention to taxi drivers that I'm a Get employee, and then the conversation were totally different. Some of the conversation were with a positive feedback, and the others not as much. I won't forget this specific ride where a taxi driver started to mention to me about performance issues that he has in the application. He was starting to show to me that every few minutes or so, the application was starting to crash. He showed me videos about it. Also, he showed me a Facebook page with a lot of other drivers that were mentioning the same thing, a similar post about crashes of the application, about bad performance issues. And he told me that he was doing his best to solve it. He was trying to contact Get representative. He was trying to actually even replace the device. And even after replacing his mobile device, the crashes were still continuing, still have the same problem. And I think that it doesn't matter from what line of work you're getting from. If it's banking, finance, mobilizing, when you're sitting down with your customer and your customer is telling you about a bug in the product, something that influenced badly as daily work, and in this case, I was talking to a driver that the application, the crashes in it, was influences in income. For me, it felt really bad, a very bad experience, and it started to make me think, how can we actually try to do a process, try to find a solution, something that will actually improve the situation that currently is in our product. So, what is performance issues? Performance issues can be described as an overuse of the resources in the system, and it can lead to some situation where the system can actually start to reboot. In other cases, it can lead to some bad interaction between the user and the interface. You can think, for example, about a performance issue, which is a memory leak. Memory leak is an example of a performance issue in the system. The memory is overused by some processes. It leads to a situation where the memory is not available for other processes. And in this way, we can see that there is really slow performance of the computer, of the software that we are using. So, if we want to think about another example, did anyone add a virus in his computer? I know I did. So, for those of you who had a virus in their computer, so in this situation, you will actually find yourself having a really bad usage of the computer. I mean, I got a virus, and this virus was actually started to consume all the resources in my computer. It was starting to consume the memory of the computer. For example, software was starting to work very slow. Everything was stuck. Even if I started to try and move my mouse, I found a situation where it didn't move. And in some extreme cases, even I got a restart of my operating system. So this is something that was designed and was actually created in order to cause this effect. In order to have a situation where the user can't use his computer, where the user actually is overconsumed by a lot of processes that are created, and since a lot of processes are created, there is no memory for any other process. And this is just one example, and we don't want, obviously, to have our product, something that we are standing behind, to do the same situation as a virus do. If we get the feedback in a network, in a social network, in some website, that our application, our software, is doing the same thing, it's something that is very hard to collapse from it. And I guess that all of you knows how easy it to get a similar feedback in social media. And this is what we are actually trying to avoid. And here we can see it's not exactly something that we consider as a performance issue, but this is an application that got some crash on the server side, and it seems like the application name Shakespeare quote of the day thinks that the quote of Shakespeare is an SSL error as occurred. And as a feedback below, it was ahead of its time. And this is the thing that we are trying to avoid. And I was thinking to myself, how can we solve it? And also on your side, how can we solve such a situation where there is a performance issue in the application and we want to avoid it? So when I was in this crossroad, I started to think, whether it's something that a manual tester can support, meaning a situation where a manual tester is actually sitting all day, testing the application. In my case, it's actually to do an 8-hour shift of a taxi driver, and all the time measuring the CPU of the application and the memory of the application. I think it's very tedious. I see it as something that is not feasible, actually, to do for 8 hours, all the time, taking the application, accepting a ride, charging the driver, and ending a ride. For 8 hours, it's very difficult, and I don't think that someone can actually pass as work by just checking this thing. So it was clear to me that the solution will be used by automation. And even then, I started to think whether it will be a solution that will be using a third party or we will develop it in-house. Developing it in-house means that we will write a solution, some tool that will measure the performance of the application. Taking a third-party solution will mean that we will download or will pay for a solution that can be found over the internet. So considering both of the things, we should also consider the pros and cons of each of the parts. The pros of using a third-party solution is that we're actually going to get something that was already designed, already was coded, created, for the same purpose that we need it. But by doing so, we need to take in mind that third-party solutions some of the time will cost money. That means that the company will actually need to pay, in some cases, a lot of money just to get something that we are asking from them. It's not necessarily something that they will deny or not provide, but it still costs money. A pro by using something that we are paying for is that we will get a support for it. We're not paying just for the solution itself, not just for the tool itself. We're actually paying also to get support for someone who is sitting behind the product and want us to continue and use it. Something that is also can be considered as a con, that if we will need to make adjustment or modification in the tool to our needs, it will be in a way that we'll not necessarily get it. Meaning we already get the solution, the tool, but it's not something that necessarily can be adapted. It's not something that will necessarily fit us completely. Maybe we need a solution for Windows, but this tool is only supporting Linux. So this is about the third-party solution. In-house solution, as I see it, it's something that has also a lot of pros because it can support you in self-development. It can support you in learning new technologies, new programming languages. And at the end, if we think about it, all of us as developers, what drives us is actually the creativity and growing up from it. So this is something we will get if we will use an in-house solution. If we will actually write the solution ourselves, we will actually program it by ourselves. This is something that we can use by doing so. Other than that, also, if we need to adjust anything, if something is changed in the product, if something need to be changed in the solution itself, we can do it because we are standing behind the code of it. We're actually writing what we need. So, in my case, when I started to think how to solve it, when I tried to use a third-party solution, we actually had something in the company, something that the company already paid for, solution that was already in our house. And we were trying to use it also for performance, but it was very hard to use, almost impossible, a lot of permissions. It was very not usable. And still, when we tried to do it this way, we saw that it's nearly impossible, and we chose to go over the in-house solution. We chose to develop our own code, to write something by ourselves that can be used to solve the problem of the performance issues the drivers have in their system, in their mobile application. And we went in this way. And even when you go in this direction, when you select to develop your own performance tool, you need to make a lot of consideration during the process. Meaning it's not enough that you are saying yourself, okay, I'm going to develop my own tool. I'm going to do it. It's not enough just to think about the idea. You have a lot of questions that you have to take in mind. Part of the questions will be, in what programming language I'm going to develop it. If some of you know, C#, for example, is a great programming language, no doubt about it. But if you write it, you will use it only on Windows. So it's a question you need to ask yourself, is it something that I'm going to do? Something that will also affect is what are the languages that are already commonly used in your company. If you are going to learn completely language from the start while you have the same language that is maybe a different language but you can achieve the same result, so maybe you'll just keep with what you are using in your own company. Other question that you need to take in mind, is it going to be on a platform which is with a mobile device or a platform which is specifically on some specific operating system. What are you going to support? You need to think about all of this before you are starting to write the tool that will serve you. You need to think about whether you are going to use database or not. Are you going to use MySQL or NoSQL? What kind of database does your product actually need in order to work? So, taking everything in mind, if you are taking also the consideration whether it's going to be with a server or without a server, if you are going, by the way, on a serverless solution, so you also think, will I use Google services? Will I use AWS or something else? Everything of these questions need to be considered before you are starting to develop the tool. And after everything was considered, we, by the way, went on developing with Java, HTML, jQuery, and Angular, and a lot of other languages. We decided to go over serverless, since it's something that we can avoid. And also use the NoSQL, even though MySQL could be work as well. We chose NoSQL because the server solution that we got using it. So it was kind of a decision that was made for us. So let's get the solution itself. This is part of what we decided. This is part of the solution that we chose, part of the tool. So obviously, we're going to test the mobile application. So the tests are going to be executed through the computer on the mobile device. And if we're trying to figure out how to continue with it, so beside the test itself, which in this case, the test, are to have an 8-hour shift of a taxi driver, we also trying to measure all the performance on the device itself. In this case, since the mobile application is on the device, we're actually taking all the data from the Android device and sending it directly to the database. This is the other part. It is important to mention that both of them are actually done on the same computer. The computer that is executing the test on the mobile device is actually on the same time taking the memory and the CPU of the application and is checking whether there is a memory leak on it, sending everything, store it in the database. Afterwards, when it's stored on the database, we can actually take all the data on the information that we stored in the database, and afterwards can create graphs from it. The graphs will show us the CPU that they were used in the application and the memory that was used in the application. This is in the same time that the tests are executed. Everything is stored in the database, and it's available for us afterwards. No matter when, we can actually go to the database and extract the data from it. And this graph is actually available and accessible from any computer in the company. So think about it. We actually get information whether there was something in the code that was done in the current build, not even in regression phase. Actually, in part of CI/CD, in a way, you can actually execute the test every night and see if there was something that was causing for performance issue, something that might lead to the application to crash. In computers, something that might cause to something similar as a reboot to the system, just because of a little change in the product that can lead to it. So since I love so much to develop automation tools, I actually developed something very similar, specifically for this conference. And this is what I've done. It's similar to what we have in our company. So it's not testing a mobile application, but it will test a web application, the most common web application. Actually, it will test Google. And it will be executed on Chrome browser. So in the same time, we're not testing only Google. We're also testing their browser, the Chrome browser. The test will be executed on the Chrome browser. We will navigate again and again. This is tests that are not lasting for half a minute, 10 minutes, or something like this. Those tests are actually executed for a very long time. It can be last for hours. And all the time, we'll save the information. So everything, the CPU, the memory, it will be sent to the database. And we will also see the graph. This is something that I wrote just for this conference, and we will see how it works very soon. So this is part of the code. This is something that I'm actually sharing with you. And if you understand, this is something that if I wrote it to mobile application, and now for web application, it can be adjusted to your needs, and it's for you to use. And this is part of the code. We can see here that we take the name of the test, and we have something that is executing with a separate thread. And on that thread, we are actually going to take the memory of the system and the CPU of the system. And afterwards, there is also something that is executing the tests. This is what the tests look like. Very Selenium, very simple. Selenium test that is navigating to Google again and again. On the same time, it's sending some value to the search field and search for it. So it's very basic, very simple, something that you can all implement. And this is something that will be executed for a long time. And this way we can actually check the stability of the application. If there is something that is wrong with it. So I will spoil ahead. There will be no significant performance issues with Google or the browser. But this is what we are doing, part of the code. Here we are getting the memory, the function that do it. Actually take the process, in this case Chrome, and it extracts from it whatever we want. If it's the memory of the application, or in the same time the CPU of the application. We will afterwards get here the CPU and the memory, using the application, the function that we saw. And in here, we are going to see the code of the HTML page. Since it's HTML, it's a very simple code. It's a declarative language. And all of us, I guess, in some way, see it in our daily routine. What we have here is the button in the page. The button calls to a function called createGraph. Here is the function itself of the createGraph. What it does, it's actually getting all the data from the database. It checks for the record that is needed, and it stores it away. From where it stores it, the graph will be created in the HTML page. And this code, what we are seeing now, it can be adjusted in a way that it will work on Windows, that it will work on Linux, on any operating system, on any application, and on any platform. And this is just part of it. Okay, sorry. Now we will have a demo. I would love to have live demos, because at the end, there is nothing better just to see how it works. Okay, and this is something that I started to execute before we had this talk. Before we had the talk, I started to execute the code itself. And what we can see is just what describes in the slides. We actually can see that we search again and again in Google for places to visit in Vilnius. And we again and again navigate to Google and do it. It's running for a long time, something like less than an hour, but still, it's just for the demo itself. Obviously, if you have a web application in your company, you can just use this code in order to check the application, the web application in your company. Can be adjusted easily. So while we are doing it, I can't actually see you that, but from the computer, we measure in the CPU and the memory all the time and sending it to the database. So it's pretty hard to see, but we do have here, this is part of the database, and this is, I guess, the part that is currently stored. And we will see that we have here all the data from the current execution. The code of the test is written in Java. The database is stored in Firebase, which is a service that's given by Google. We're using the database of Firebase. And by the way, all the measurements, the memory and the CPU that are taken at the same time from the execution, it's something that is checking the UI itself. We're not checking whether there was a long time for the data to get to the server. We're not checking anything from it. We're actually checking the client. We're checking the front end of it. We want to see if anything in the application, in the UI side, caused for anything to have some influence on the performance of the application. So this is the tool itself, at least the visual side of it. We can choose here the name of the test. Afterwards, we have here all the times that the tests were executed. We can see that the last execution was on the 17th of October in 1:40. So this is the execution that we've started before. We can choose here wherever we want to see the memory or the CPU. I actually think that the memory has a lot of information in it most of the time. When we actually used this tool in my company, the first thing that we've done was actually a memory leak. So again, we're testing in Google, there will be no memory leak. But what we've seen, like a graph. And I'll show you the graph now just to see how it's performed. And we can see that we have here some inclination, but it's so little. So it's nothing that I would consider as a memory leak. But when we used it, we actually see like spikes all the time, and like something that was rising in a very different values, like much higher. But this is the memory of the browser while it's searching in the Google engine. Other than the memory, we have here the CPU that was measured in the same execution. So something that we need to see, that there are values that are pretty high, but it's like 1 point or another point. It's not like most of the points are in high values. Most of the values of the CPU are actually really near to 0, so it's very good. And this is part of the tool itself. And again, it's something that if you use it in a generic way, and I can promise you that this is what I try to do, you cannot support only, let's say in this case, the Macintosh operating system. You can also support Linux operating system, Windows operating system. The changes are very small. It may be changed in the way that you take the values of the process that you are testing, but nothing more than that. And in the same time, it can support any application that you can think of, whether it's a mobile application or a web application. So this is about the demo itself. Again, in a company that you are working, and anyone that has the link to your tool, you can just access it and see the result. The beneficials of it, that it's not only that you see whether there was a memory leak or any performance issues, you can also at the same time see if there was something that was changing the build itself, since it's executed nightly. And it helps to the developer actually find the specific build that it was started. So this is the demo. I want to summarize and just say that the way I see it, to think out of the box, to be creative, something that can push all of us forward, something that all of us trying to do in order to succeed in our work. This is just one quote that I found very fast about creativity, and as it was said, creativity is intelligence having fun. And I want you to see it the same way. I really hope that you'll get out of this talk and take it with you. So, thank you.